Hey guys, in this video I'm gonna be solving this problem. So the question is, prove that the following subspaces are supplementary. So we have two sets, and this F is span of this and G is span of this. Okay, so before we prove that, you need to understand what supplementary is. So if you want to prove that F and G supplementary, you gotta show that F and G it's a zero vector, and then F plus G is E. So such that for all W in E and there exists, you gotta show that there exists U in F and there exists U in V in G, such that V is equal to U plus V. So this is the main idea. This is how you prove it. So before I solve it, I just want to give you the main structure of what we're gonna write and how we're gonna solve this. So always you're gonna be given F and G, and then you're gonna prove that they're supplementary. And always, like, you have two steps. The first step is you want to show that it's zero vector, and it's like this, like 0 0 0, and then you say like this inclusion is evident, and then this side is just like proving left to right and right to left. So this side is always evident, and in order to prove this one, you say let U is F and G, and you da 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 da, and then you gotta show that U is zero vector, U is 0 0 0. And in step 2, you gotta show that F plus G is equal to E, and this inclusion is evident. And then this is, in order to prove this one, you say let V is E, and then you gotta find U and V. U is in F and V is in G, such that V is equal to U plus V. So this is the main structure, this is the main pattern of what we're gonna write. So we're gonna write this, and then this, and problem solved. Okay, so let's start. So the first step is you need to show that F and G are zero vector. So always you say the inclusion, it's evident, and then in the next step, oh okay, now you can say it. Okay, in the next step you gotta prove this inclusion. So you need to write it on your exam on your worksheet. Okay, so in order to prove this, you say let U is F and G, right? From this we can easily decide that U is in F. Because of this, you can say U is in F, and from this you can easily get there exists let's say lambda 1 and lambda 2. It's in R square, comma, where U is equal to lambda 1 times 1 minus 1 1 plus lambda 2 times minus 2 1 minus 1. Okay, where did I get this? I got this from here. So I'm gonna use my red marker right now. So if you have F, right? So if we say U is F, I mean, because of this, you can get U is F, and then because of this, I'm having this one. And now, similarly, we say V is G, and from this you can get there exists, let's say lambda 3. This is R, oops, and V is equal to, let's just say, no, we are saying not V, it's U. U is in G, and then there exists lambda 3, and then U is equal to, on the other hand, this, and then 1 2 minus 1. I'm getting this because of this span 1 2 minus 1 1 2 minus 1. So I have this 2 right now. So I have this 2, and on the one hand U is this one, on the other hand it's this one. So I just want to check what is U minus U. It's equal to 0, right? By comparison, right? So based on this, on the one hand U is equal to this one, on the other hand U is equal to this one. So I'm gonna type it out right now. So first lambda 1 minus 1 1 plus lambda 2 minus 2 1 minus 1 minus lambda 3. The second U is on the other hand because it's G in G. I gotta type this one. I can 1 2 minus 1, right? Equals, and instead of 0 I should say 0 vector 0 0 0. And because based on this you can have it's very easy, right? Lambda 1 minus 2 lambda 2, and this is minus lambda 3 is equal to 0. and on the second line minus lambda, this is 1, right, plus lambda 2 minus 2 lambda 3 is equal to 0. Okay, and lambda 1 minus lambda 2, this is just basic calculations I'm gonna be doing quite faster. So let's just say this is 1 2 3. Okay, 1 2 3, and first step, 1 plus 3 gives you 1 plus let's just say 1 plus 2. 1 plus 2. 1 plus 2 gives you, okay, lambda 1 cancelled, so you have minus lambda 2 minus 3 lambda 3 equals 0, and then 3 minus 1, third equation minus the first one, gives you, what does it, lambda 1 bye bye, so lambda 2 plus 2 lambda 3 equals 0. I'm just doing addition and subtraction. I hope you get it. It's very basic calculation, right? Okay, from this, if you just add this, you have lambda 3 is equal to 0. I mean minus lambda 3 is equal to 0, and then lambda 3 is equal to 0. And if lambda 3 is 0 here, lambda 2 is 0, and both of them 0, lambda 1 is 0. So we have lambda 1 equals lambda 2 equals lambda 3 equals 0. What does it mean? It means that u, like in both cases, like lambda 1, lambda 2, lambda 3, 0, u is equal to 0, 0, 0. Or u is 0 vector, right? So the first step is proven, and now the next step. So in the next step, we need to show that okay, let me, before I say, I wanna let's just focus the video. Okay, in the second case, you gotta show that E is equal to F plus G, and the inclusion this side is always evident, and then the inclusion this side. So you gotta show this side. Okay, so in order to prove this one, you just simply say let V is equal to X, Y, Z, and which is in E. Then we have V is equal to, let's just say minus X plus 3Y plus 5Z, 1 minus 1 1 plus minus X plus 2Y plus 3Z, minus 2 1 minus 1 plus, okay, can you see it? Okay, I'm gonna write it here, plus Y plus Z, 1 2 minus 1. Then V is equal to F plus G. You might be like, wow, what is this, right? So if you focus, this is in what? This is in F, because F is span of 1 minus 1 1, 1 minus 1 1, and then minus 2 1 minus 1. So it's just here. And now, and this is what? This is in G, because the span is 1 2 minus 1, right? 1 2 minus 1. And if you write this one and you stop here, you get the the full score on the exam based on my professor. But if you're wondering how do we get this one, like this X and this and this and this, if you know how to get this one, you don't have to watch the rest of the video. But if you don't know how to get this one, you can continue. But if you already know, you don't have to watch this. So this is what we're doing on your draft, what you'll be doing on your draft. So on your draft, you have to find this U and V. So in order to find this on your draft, so let me use another marker. I'm gonna be using this marker. Okay, so in here, so we say this is on our draft. So we say let's just say U is equal to A 1 minus 1 1 plus B minus 2 1 minus 1. So basically, as you can see, U is in F, and now we say V is equal to let's just say C, which is minus 1 2 minus 1, and okay, so, and this is, let's just say G. So because it's on the draft, I didn't say there exist A and B and C blah blah blah. I'm just doing the calculation. So basically I gotta find, we gotta look for v is equal to u plus v, right? And in our case, what is v? So we say, let's just say we gotta find v, and v is in E, and it's x, y, z. Okay. Now what is v? X, y, z, right? And what is u? U is a times 1 minus 1, 1 plus b minus 2, 1 minus 1. And what is v? v is c times 1, 2 minus 1. So now we need to find a, b, c. Then you can find u and v. It's just clear. So from this we can get what? X, y, z equals, so this is a minus 2b plus c matrices, right? Minus a plus b plus 2c. So a here, this is minus b, and this is minus c, right? I'm just adding this matrices. Okay, so from this you have a minus 2b plus c is equal to x minus a plus b plus 2c is equal to y. A minus b minus c is equal to z. So I have this c, so this just say this is the first and second and third equation. So now we need to express a, b, c in terms of x, y, z, so that we can put them, we can insert them here. Okay, so and again it's so we have 1 plus 2. 1 plus 2, if you had 1 plus 2, the first equation, and then the second equation, you have minus b plus 3, c is equal to x plus y, right? And now let's just say 3 minus 1, the third equation minus the first equation gives you what? b minus 2c equals z minus x. And from this 2, if you add this one, you have c is equal to y plus z, right? And now this is the first and second. Let's just take this one. So b minus 2c equal to z minus 2. So b minus 2, what is c? c is y plus z equals z minus x. So from this you can get b is equal to minus x plus 2y, y goes here, and then plus 3z, right? And then lastly, let's take this one. So a minus 2b plus c is equal to x. So a minus 2, what is b? Minus x plus 2y plus 3z. What is c? c is this, y plus z equals x. From this you can easily get, so you can get minus x plus 3y plus 5z. So you stop here on your draft. So basically you find u. What is u? u is, this is u is what? u is this, right? Oops, u is this. And a times, what is a? Minus x plus 3y plus 5z times 1 minus 1, 1, plus what is b? b is minus x plus 2y plus 3z, 2 minus 2, 1 minus 1, and v is equal to c times this. What is c? c is y plus z times 1, 2, minus 1. And of course w, can you see it? Yes, w is equal to x, y, z, meaning that w is u plus v, and in here u is in f and v is in g. And I'm gonna go back here because see, we showed that this is u and this is v. So it's obvious it's included in f and it's in g because of the span. This span is obvious. So this is it. But on your exam, you don't need to show this. You don't need to show this calculation. This is just on your draft. But you gotta show this one always. Okay, so that's it for this video. So let me review, let's do a recap. Always you're gonna be given like 2 and then you gotta prove the supplementary. So you have 2 steps. If the question is supplementary, you have 2 steps. First you gotta show this 0 vector, and then this is evident, and then in order to prove this inclusion, you gotta say let u is this, and then u is equal to 0 vector. And in the step 2 is the same thing, f plus g is equal to e, but this is always evident, and then in order to prove this inclusion, you gotta say let w is equal to plus e is in e, and then you gotta find e in f, u in f, and v in g, which is w is equal to u plus v. Alright, that's it for this video. Bye bye.